Hey people, welcome back. Hope you guys are keeping well. Today's video is about troubleshooting graphic chips. There's quite a bit of explanation to do, so do sort of bear that in mind. Okay, so this is an older generation laptop. It's a DV7 laptop basically. Now a lot of them are obsolete and so on and so forth, but this is a good example of how to troubleshoot. You know, there are certain parts of the world that are still sort of utilizing these computers to its full potential, so maybe it'll help them, maybe not. So the symptom of it is power on no display. Okay, I've got the bench power supply set here at 19 volt and it's drawing at the moment 0.011 amp. Okay, so let's power on. We've got a fan spin, the LEDs, you've seen it blinking, the standby LEDs are on. Okay, but I'm not getting any display and it's drawing 2.13736 amp. Okay, so I'm going to leave that running. Now I have checked all the other voltages basically. Alright, the trouble is that for me to move about with the LCD being on, it's a bit awkward. So what I'm going to do is I'm going to remove the LCD. Let's just power it off again. Disconnect the power supply. Remove that. Okay, and let's just poke around and see what voltages we're getting on these certain part of the board. Basically, are we getting all the voltages, the required voltages? Basically, let me put it this way: if the power goods rails are down, or you know the critical rails are down, on a board will not turn on. Right? Okay, so we do have all the power. I have checked. We do have all the power rails present. Basically, okay. So let's turn the board back on. Okay, let's get the multimeter in view. Fuck off here. A lot of stuff on the bench. Right, so that's your multimeter in view. All right, let's get me sharp pin. All right, and I'll start probing around. And just to sort of make you aware that it does charge the battery. The battery's charging fine. Okay, but the symptom is no power, power on no display. Ground. Okay, so we'll start off with the let's see what we've got here. Is that's your RAM supply? That one, that'll be your battery charging coil that sits in between the connector and the after battery charging IC. That's normal. Okay, let's see what this is. That's your 5 volt. That'll be your 3.3 volt. Let's see, the trouble is I can't. So many stuffs on the bench. Okay, what do we get on the 3.1? Okay, let's move on to this side. And the trouble is that I'm accessing, because the heatsink is on, it'll be difficult to access, but that is a graphic chip supply, 1.125. Do we have V-core, CPU V-core? I need to I can't find it here. I'd like to probe around on the coil basically. Oops, I did get that. That's your CPU V-core. Okay, just randomly poking around. That's something else I was looking at. And is there anything else I'm missing out here? Yeah, just to confirm that the battery is charging, so the voltages are present. Just okay, and the rest I'll have some of them at 3.3. Okay, 0 volt, that'll be 3.3, and it will drop as soon as the battery gets connected, and those are your ground pins. Right, okay, so all the major coils have been tested and there are the voltages, the required voltages are present. Okay, microscope. Okay, so that's your BIOS IC. You can see, and I can assure you that there's nothing wrong with the BIOS. I've flashed the BIOS as well. Okay, so pin 1 on the BIOS IC is the one with the little dot here. That's your pin 1, so it works in anti-clockwise. So that's pin 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's probe around the whole pins and see what we get on the BIOS basically. Okay, that's normal for pin 1. That's normal. The data sheets are available on the internet based on the model number of the BIOS itself. pin 4, nothing on pin 4, pin 5, let's start with the pin 5 again, pin 5, pin 6, pin 7, and pin 8 will be ground, should be. Hang on, sorry, it's pin 4 that's ground, pin 8's got a voltage, my apologies. Yeah, it's pin 4. So, okay, well, what we're going to do is we'll compare the bias voltage on a working board. So this is a working board, basically. So let me power on the board. Okay, so the board's powered on. And let's probe around the BIOS chip and see what voltages we get, basically, so that we can you can see the comparison, basically. So let me sort of start with pin number 1. Sure that I'm getting a good contact. That's pin number 1. Yep. Pin number 2, pin number 3, pin 4 will be ground. Oops. Pin 5, pin 6. Oops. Just sort of pin 7. That was. It's just beeping like a dickhead for. Yeah, that's switching the board off because it's some sort of a data line, that basically, of some sort. Right, okay, so we're not going to try and measure that basically anymore before it corrupts the BIOS. And that's pin number 8 basically. Alright, so every time I touch pin number 7 it's switching off the laptop basically. So that's well, the board I should say. That's the comparison with the working board basically. Okay, so first thing first is that you want to look at the LCD connector. Okay, let's look at the LCD connector. Where's LCD connector on the BenQ here? Okay, so on the left hand side where you see you got the LCD connector. Okay, and what you see here there is your 3-port LCD on. So pin 1, 2 and 3 has to have a 3+ for the LCD to come on basically, and that'll go through this inductor which is L1. It's a tiny inductor. It's I believe it's a 0802 package, 0803, whatever it is. Let me get the exact size. I'm just getting a bit carried away here basically, guys. It's 0805. Right, just to correct myself because it's just getting a bit tiring for me today basically. Okay, so effectively you must have voltage in here. Okay, but what we'll do is I'll start from pin 1 and I'll check these voltages basically, if they're available. Right, so let's get this back under the microscope. Yeah, there is heat being generated by the CPU and by the south bridge, or north bridge I should say, but there's no heat from the actual graphic chip basically. Although that the graphic chip's VCore is still available, it's not sort of sending the signals out basically. So let's get this. Let's transfer over to the microscope view, and the trouble is I've got a metal base and don't want to sort of, although that the board is scrap board, still want to sort of keep the board for testing purposes basically. Alright, okay, so the pin 1 starts here and it goes all the way down to pin 40. Okay, so let's look at pin 1 and 3. They're all connected. Okay, so I'm going to sort of, because they're so close to one another, I'm going to probe on that cap basically here. I'm getting absolutely nothing. Okay, absolute nothing here. Okay, so that'll be pin number 4. Okay, and what do we have on pin number 4? Yes, there's a voltage input, as you can refer back onto this here. That's pin number 4, and that's showing +3 volts. So we have that presence. These are data lines basically. So I'll probably be a good idea turning the oscilloscope. I'll do that very shortly. But let's look at, ignore all them. Let's look at pin number 35, 36, and 37 basically, and see what we get there. I'll go back to pin number 35, 36 and 37 because I don't think that the screen capture caught that. It's 18 volt, 18.2, and then I'll be checking the +5, which is pin number 39, and I'm getting 5.1 volt. Just to confirm that pin 1, 2 and 3 has got nothing, and pin number 4 has +3 volts, so I'll just, yeah, so that's 3.335. Okay, what I'm going to do now is I'm going to take the measurements with the LCD on this faulty board basically. So because that the power on the display DISP-on the 3 voltage +3 volt 3.2 whatever the voltage is basically, that should be available with the LCD being connected basically. So what I'm going to do is I'm going to sort of make a clarification of that. So let's put the LCD back on. Okay, I'll power up the board and let's sort of get the power supply in. So the LCD is connected, definitely. Okay, let's put this on and I'm going to power on the board. Board's powered on, and I hope you can see the multimeter as well. And sadly I can't show you the pins on the actual under the microscope, but what I can do is I can sort of do it that way. Okay, so hope you're watching this. Right, and I'm going to probe on pin number 1, 2 and 3 on that capacitor, and I'm getting absolutely nothing. Okay, let's do that one more time. Yeah, so even this screen attached, I'm not getting any voltages basically. So okay, let's put that away for now. And okay, so what we're missing now is the +3 volt, which is, oh come on, we're missing this. That's what's missing here. Okay, that's the voltage, that is the bit that's missing basically. So I've opened up another schematic basically just to keep things short and simple. Okay, that gets created, this +3 VLCD gets created from this circuit here basically. All right, this comes from here onto there. Right, so this circuit has to function properly. So I've checked this circuit around. There's various voltages on these transistors basically here as well, but not the correct voltage for this circuit to work fully because the input is missing here. The display this DISP underscore display underscore on basically, I should say, that the signal is missing here. This should have a voltage basically. Now let's track back and see where this is coming from. Okay, because this is the breaking point of figuring out if the actual graphic chip is messed up basically, right? So let me just open up the board view. I've already sort of, let's just get this board view opened up and let's move on to that. Okay, right, so this is the video chip, which is a U3006, your North Bridge, which is U32, and your CPU basically. Okay, so let's sort of open up the search. Okay, and it's already on there. Let's click onto that, and guess what? Pin 46, which is display pin 246 on the U3006, which is the graphic chip. It's an ATI graphic chip. That sadly, this circuit, what I've said before, let me switch over. This circuit and this signal coming in, this arrow means it's going in. This signal comes directly from the BGA chipset basically. So this is where it's coming from here. Now to probe back, and let me just see if I can find a test point somewhere. There is a test. There should be a test point. Let me reverse the board. There you have it. Okay, So that's the opposite side of the board, and there it is. This is the old LCD connector basically. Oh no, sorry, this is the LCD connector. This is, I think, the webcam, whatever it is, but this is the LCD with the 40 pin basically, right? Okay, so oops, come on. Right, let's click onto the pin 1, and that should highlight the areas. Okay, those are the areas, L1, but I think I made a bit of a let's put find again. There we go. And that comes, as I said, from the actual video chip basically. Let's go back. Okay, so let's check these areas and see what we get basically on these transistors and this little resistor basically, which is an R17. So let's locate this under the camcorder. And as I said, this is your connector. Let's look at R17, you can just about see it. Let's see what we get. Obviously we're expecting nothing on that rail. Okay, so R17 is this resistor there. Okay, and sadly this power switch is on the way. There's nothing on right hand side of that resistor. Just make sure I've got a good connection with the ground pad. There's nothing, and there is nothing on this side either. Just to prove my point that I've got a good ground. Yeah, there you go. So there's nothing here. Okay, so let's check the transistor above and see if I'm getting anything on that. Absolutely nothing. Absolutely nothing. And there's 5 volt there basically. Okay, but the critical leg here, I'm getting nothing basically. Right, there's one more. No, I think that's about it really. Let's look at the L1. That's the inductor. Should have a voltage, this inductor here. So what do we get on either side of this inductor? Absolutely nothing, because that sits in between the plus 3V3. Let's switch over to the this is where it sits there. Okay, this is the L1 here. All right, so I've got nothing coming into these pins basically, and as I said, when you backtrack it, it's going back to the BGA chipset basically. Right, let's probe around those transistors and that R17 resistor with the LCD on, and I'll check the L1 as well. Just for a little confirmation basically. Right, okay, so what I'm doing now is I'm checking the both side of the R17 resistor. Got nothing on this side, right hand side, nothing on the left hand side, and I'm checking the pin where I got 0 volt on that transistor, which is linked with the R17, nothing. And then I'm going to jump into the L1, one side, and obviously if one side has nothing, the other side most likely will have nothing. So that's been said, with the LCD connected to the board, I'm still getting nothing. So I think pretty much there you have it, that this is what the issue is basically. Now I have a working board, and I will have to transfer some of this stuff over to the working board now. Okay, so just bear with me for a sec. Let's move all this away because this thing is absolutely congested, the workbench, with everything that you can possibly think of. Okay, heatsink's off. Let me get a flat screwdriver so I can take the CPU out of the socket. There we have it. Okay, so that's the faulty bod. Those have come off, so let's put that on the right hand side of the bench. Okay, and I've got a working bod which already has the heatsink installed. Okay, let's put the CPU in the socket. Okay, we're quite happy with that. There's already thermal paste applied, so I'm not going to bother with putting any more. As far as I'm concerned, that's all good. Okay, let's slam that in to its place. I'm not talking them all individually, fully. Tighten them fully, I should say. Now I'm going to do that, but I'm going in a kind of a crisscross. Okay, just nice and gentle with it. Okay, so I'll give it one last final, because I'll be using this board actually. I know some of you might think, oh well, what the hell, man, this is all, but as I said, there are third world countries where, there are countries that are still utilizing these laptops to a full extent, so videos like this could be potentially helpful to them basically, but maybe not to ourselves. But there we have it. Right, okay, so as I said, this is a working board, and I'll prove that to you that it is working. So first thing first is I'm going to connect the display. I'll do the voltage reading. Look, if it powers on, right, most of the power rails are present, so you don't have to worry about that for now. Okay, so, and the reason I'm saying this is that I'd like to probe around all the thing, which I may do, just to sort of prove a point basically. Right, that's all in. Okay, the power board's on. Okay, so I'm going to connect it to the power supply, and that's doing exactly the same behavior, 0.011 amp, and I'm going to power it on, and we should get a display. I'm still getting drawing that amp, and there you have it. Okay, so power on, display on. Okay, so let's do a quick measurement. Okay, I don't need to check all the other coils and everything, because obviously if those coils had an issue, then this won't come about where it's come about basically. Okay, so let's get a good ground. Probably just hold it there. Okay, now let's look at the R17. R17. Now I'm getting 3.258. Okay, the Q3, I'm getting 3.258 again. Okay, so this is where the Q3, let me just find this for you. Q3, okay, let's just switch over to BenQ. Okay, that's your Q3 here. All right, and this is the input, and I'm getting nothing here basically on the faulty board, but I'm getting 3.258, whatever it was basically. Let's just confirm that. 3.25758, and that this signal comes from the BGA chipset basically. Okay, and we've already proven that through here. So for example, let me sort of go back, okay, and if you look at the pin 246, pin 246 is this DIS underscore on. Okay, and you refer that back onto the schematic, it's exactly the same title basically. So that it ties in with the graphic chip basically. So that signal comes from the graphic chip, and therefore because that signal is missing, that the display is not coming on basically, and that happens purely because of the fact that it's a faulty chipset. That on the multimeter, I don't think you did you? that's on pin 1. Okay, so look, at the end of the day, this is just a basic idea of how to sort of troubleshoot a graphic chip related issue basically. And this is a graphic chip related issue because when the board came in, it came in with power on, no display. It'll switch on and it'll switch off, or it'll switch on and it'll stay on forever until you switch it back off again, and you'll have to keep on holding power down button down for several, say about a second or so, when you should be straight poke and let it go and it'll turn on. But in his case, you've had to hold it on for about a second or two, and then the laptop will turn on. So and he said that it's happening. It started happening for the last couple of months, which is an early symptom of a graphic chip failure. So what I did for him is I've reflowed the chip, just so that we can try and see if there is a quick patch up. Unfortunately, reflow and reballing is absolute bullshit, and I don't dismiss that basically. But sometime you may have a dry solder joint under the BGA chip, which is rare, but it can happen, and that's one of the reasons why I did what I did basically. After that, the board was totally kind of like dead. There was no display, no matter how but no display, completely kaput basically. So then what I've done is I've replaced the BGA chipset. Now the chipset what I had, I was led to believe that this was a new chip, but sadly it turned out to be a faulty chip basically. It was new because you can tell by the PCB colors and everything, there's no scratches, nothing whatsoever. I was quite confident that that would resolve the issue. Once I've actually put the new BGA chipset, same symptom, power on but no display. There you have it. It's a graphic chip related issue, and I will just quickly recap basically. So we require three on the LCD connector. We require this plus 3 points, so it's 3.258 we've established now. That's the voltage that needs to be here for the LCD to come on, providing that the LCD needs to be connected. Okay, so it detects the LCD, and this gets created through this circuit, and you have to have a 3.2 volt present here, and this comes from the BGA chip, which is up here. No. This gets created here. It's a display DISP_on, and that goes all the way to the opposite side of the board. This is the BGA chip U3006, and that goes to the opposite side where the resistor is the R17 and this Q3. So when you look at this particular circuit, what you will find is, let me just make sure that this is, what you will find is that this is the circuit what I was referring to on the schematic before basically, that creates the 3.2 volt for the LCD on basically. So this is the R17, and they're all interlinked. If you look carefully, they're all part of the same circuit basically, all the way to the L. And then the inductor then sort of transfers that over to the pin 1, 2 and 3 basically, and there's a small capacitor that's sitting there basically. So that's how the circuit is interlinked, and that's one of the reasons why we're getting no display basically. So there you have it, guys. Hopefully that you've found this video informative. These issues are very, very common issues basically on the older generation of laptop. Sadly, the BGA rework market has sort of declined quite significantly, but that doesn't mean that I'm going to redundant my Jovi 8500. Absolutely not. New processors, new chips are on a BGA, CPUs, which has built-in graphics, CPU and the PCH. They're in one die. For example, like the Intel CPUs, sometime I've had issues where there are cracked solder joints, and I've reflowed the board, and they've never ever come back to say that there's the problems. They're having problems with the laptop. So yes, the Jovi is handy, and I am not going to let go of it basically. Whether you want to invest one or not, it's going to be very hard for you to get hold of a unit, because the manufacturer's gone bust basically. When I say bust, they're closed. So any machines that are lying around on the internet is what's available. So there you have it. Right, guys, what I'm going to do now is, next thing to do is to reassemble this unit fully, put everything back together, and with the working board, and just pass it on to the customer, and we'll take it from there. This is an old unit, but I don't know, as I said, he's very attached to this unit. Whether his dad bought it or somebody bought it or he bought it himself, I don't know. But see, he seems to be very attached, and he was telling me, just do whatever you need to do. I need this unit fixing, basically. I did everything. I've exhausted all possible resource to try and get this done, but sadly the BGA replacement didn't work out in my favor. So this board, that one, okay, is going to be a scrap board for me. And if you're looking for the chip, I do have the chip. Let me find the chip for you, and I can also tell you the part number on the chip as well. There's flux on it, so I'm not going to touch it with my bare hand. It's a tacky flux, so there you have it. Okay, part number. If you want to know what the part number is, let's sort of switch over to that and I'll show you. There's the part number. 2160778. You're a 6. Hang on a sec. Get some IPA on it. Get it nice clean. Yes, it's an 8 actually. 8014. That's the part number basically. So when you look at things like this, where you're looking at the part number here, and that's the date code, week 35 2009, when it was manufactured. Okay, and the one I put on that board was slightly later. Let me grab that board. You know, funny, I've had 2 chips in that thingy, basically batch what I bought from China a while ago, before all this COVID came about and all that, and then I've fixed a laptop with one of the chip, and I was a bit surprised when this turned out to be, and it's the same chip here as well. Okay, but this is date coded week 22 2010. Now anything like this type of date, I hand on heart, I know that the chips should be new, but sadly in my case this turned out to be faulty. So yep, that's all guys. I am going to conclude the video now, and enough said. Stay well, stay safe, look after yourself, and I'll catch up with you on my next video. Peace.